Welcome to Altair Engineering Training and Support. I am Apur Bapat. Welcome you all in Altair Optimization Contest 2015 webinar, which is based on how to solve the contest model of AOC 2015 for linear, non-linear problem, that is OptiStructure and radius stream. So in this stream we have given two components, which are part A and part B. For part A we have given linear static analysis and optimization, and for part B we have given the nonlinear implicit analysis. For part C and D are user defined, so accordingly you have to solve as per your choice. In part C you have to do the linear static analysis and optimization, and part D you have to do the nonlinear analysis using radius. So in the first part, the problem definition and inputs are given. So accordingly we will try to solve this in HyperWorks Student Edition version 13. So I will open the HyperWorks version 13 Student Edition. Select the user profile as OptiStruct because I am going to perform a linear static analysis and then I am going to perform the optimization. So I will select the user profile as OptiStruct. Click OK. It will load the required templates. Now I will import the model. As I can see, the models provided to me are in IGS format. I think you have downloaded this folder, a zip folder which I have provided to you. In that there is a part A and part B. So this is in IGS format. So I will import this model. Go to import icon, geometry, select the file. So I will just copy, open, paste and select this file and click on import. So once you click on import, you can see it has two components and with a surface. You can see the surfaces. If I click on mixed, you can see there are some mix matched in the surfaces. So we have to first correct those mismatched areas and then we can proceed further. So I will start with editing the geometry. So in this way I have to edit the entire geometry. So now I have edited the geometry. As you can see, still I have some patches left to edit. So before going further, just I will quickly check the geometry. Now I will again go to this portion of the problem definition and rename it as hull and ribs. Now I will create material as steel, define a color, type isotropic, card image mat 1, create edit, E new row. Then I will create two properties because I have two different components. So first I will create ribs via color, 2D, P shell, material, create edit. I have created ribs property. So the thickness of ribs is 13 mm. And I will create a hull property, 2D, P shell, steel, create edit, for the thickness of 19 mm. I will update the components with the respective properties. So ribs is assigned to ribs, update. Hull is assigned to hull, update. Then I will go to 2D auto mesh, select the surfaces. It has given that element size should be 50, so I will put 50. Element to surface component, first order, keep connectivity, everything as it is, and click on mesh. So my meshing is done. You can see the elements. So I will off the geometry. Quickly check the connectivity. So to check the connectivity, press Shift F3 from your keyboard and click on preview equivalence and find edges. So all the edges which has been created has to be at the proper location. So if you can see, all the edges are in the proper location at the edge of the surface. If it's in between, then something is wrong and I have to fix it. So you can see nothing is wrong in this. So everything is in correct position. So okay, so something is wrong in this, which is this area. So this area has got the elements properties of even the other areas also. So I will delete this component on the surfaces and delete the elements. So while editing, the surface moved to a different component. So now I'll press Shift F11 from the keyboard, select surfaces, select the surface which I want to move to a particular component, that is ribs, and move. So now I move this surfaces. I can directly move the elements also, but moving the surfaces is always better. So keeping all the other parameters as it is, I have moved it. Again, press Shift F3, select the elements, preview equivalence, and find edges. So I will find that there I am not finding any edges in an appropriate location. Inappropriate means somewhere here. So there has to be a proper connectivity. So that is now it is connected. So I will delete this. Now I apply loading conditions. We have to apply distributed pressure on hull complete surface of 1630. So I will create a component load collector as pressure, defining a color without a card image, create. Go to analysis page, pressure, select the element by face, or select by component. So I will select the elements by collector and select hull. Nodes on face also by collector, hull. The magnitude is 1630 and create. So you can see the direction of the loading is not proper. You can see some of the other elements are not coming properly. So I have to first do this normals of the surfaces equal. So I will select elements by collector, select, orient to this and adjust normals. So if I click on by collector, hull and display normals, still I am getting some of the elements normals in opposite direction. So elements by collector, orient to this, adjust the normals. We will click on elements by collector, hull, select and display the normals. So as this is not getting proper orientations, so what I will do is I will deselect this. I will select remove the hub and I will change it to select display color. So these are the elements. Now I will again select display normals. So I will select this, and this and click on reverse. display normals, shift F10, elements, display normals. Adjust this normal with this. So shift F10, display normals, so I will select them one by one and deselect these. Reverse the normal. Again, display normal. So this is done. I will select these and these and say reverse. Again, I will select all display normals. So I will select them. These also. Say reverse. Again, shift F10, select the elements and display normals. So now the normals are in the proper direction. So while applying the pressure, it is most important to have the normals of all the elements on the surface of which you are applying the pressure have to be in the same direction. So again, I will select the elements, the nodes. The number of elements are 1960. So I have 1630. So 1630. 1960 divided by 1630 is this much amount of 1.2 Newton of pressure or 1.2 MPa pressure I have to create, but I have to check the directions. So you can see the direction is in opposite. So I have to reject them and apply a pressure in negative direction. So it will be an upward. So what I will do, I will change the size so it is visible. You can see now. Now I will turn off this, turn on this one. Now I have to apply constraints. I will create one more load collector as constraint, that is SPC. Define a color, click on create. And as per the problem statement, I have to create a constraint at the outer edge. So I will constraint all the degrees of freedom. So analysis constraint. So I will select all of them. I can use node by path to have a quick selection. Then node by path. So node by path has an option for quick selection process. Or else I can do one more thing. I will select the entire portion instead of selecting one, because I just want to show you how to solve these. So that's why I'll not put so much of time on these things. So you have to select the edge only. So this is done. Then I'll go to analysis, load step, create a load step as pressure or whatever name you want to. Create the SPC, create the load and click create. Now save the model. I will save it as part A. Then analysis, OptiStruct, and run this model for the linear static analysis. So my analysis is completed. I will see the results. So my displacement is coming as 3.98. This is not a correct displacement as I have put it so much of constraint on this model, and my stress value is 475 Newton per mm square. So I will note it down because this is required for the size optimization. Now I will close this and create an optimization process. So size optimization, hull, it has given that perform the size optimization to initial thickness of rib and hull and reduce the stress and displacement. Create a design variable for ribs using initial value as 13 and lower bound as 6.5 and upper bound as 19.5. So I will create one for ribs, initial value as 13, lower bound as 6.5 and upper bound as 19.5, and click on create. Similarly, I will create one more for hull using initial value as 19, lower bound as 9.5 and upper bound as 28.5, and click on create. So I have two design variables, rib and hub. Then I have to create two responses as stress and masses. So responses, one is stress, that is static stress. I will select both the properties, go on my cells and click on create, and the other one is mass, that is mass, and click on create. I will constrain it as given. Design constraint on stress of the upper bound 360 Newton per mm square. So I will constrain it for stress pressure for the upper bound of 360. Create, and the objective is to minimize the mass. I will again save the file. For the optimization, OptiStruct, optimization, and OptiStruct. So I got an error stating that there are no topological reference design variable. Use the analysis keyword to perform the analysis. So this means I have to create a generic relationship between the ribs, design variable ribs, return, create, and hull, property of hull, return, create. Then I will save this file, analysis, optimization, and yes. So the error is coming because I haven't put the generic relationship. So before solving these problems, you have to make sure that you solve the models. So I have the elemental thickness as 24 to 6.5, and if I want to see the stress values for the same, so I got a stress lower than the initial, that is 475. Now I got a stress of 309 Newton per mm square. So I have changed the thickness of this component, and accordingly I got the stress result. So in this way you can solve this model. Now I'll close this and move to the next model. So the next model is of boat, that is for the impact analysis of boat. In this the material and properties and everything has been predefined. So I will start with importing the model. So I will first import the model, which is part B, import. So I will check the connectivity first. So you can see there is no issue with the connectivity. I will change the user profile to radios because I am going to perform the dynamic analysis. So I will change the user profile. So accordingly I will get the card and everything. So I will rename the component as boat, create the material as, say example, elastoplastic. Define a color, type elastoplastic, card image M2 plus, and giving the values of row initial which is at 7.8 e to the power minus 6, so 7.8 e to the power minus 6, then value of E which is 210, then new which is 0.3, A 0.26, then B is 0.450, N 0.5, EP max is already it has taken. Any other values I don't have to provide, then return and again return, then go back to the properties for boat, define a color, type surface, card image, P1 shell. I can give the thickness here or I can give the thickness in the card image also. So this is thickness it already taken. So I have to give the value of HM, HF, HR and DM and A SHER, share. So these values I have to provide. Then click return, again click return. Now I will update the component, select with the card image part, property as boat, this as elastoplastic, update. Now I will mesh the component, say with the element size of 15, then return, again click on return. I will create one more component as R body with no card image, no property, no material and somewhat different color. Click on create and now I will create a rigid wall. Generally while creating an imposed velocity it creates in a positive direction, so I will reflect this model. So I will use the reflect command, elements in X direction with this as the base point. So I have reflected this. I can also reflect the surfaces. So I will select the surface, reflect. So now I'll create the imposed velocity. It will have the proper direction. So generally it takes in positive direction. That's why I changed it to positive direction. Now I will create a rigid body. So I will go to 1D, rigids, select the multiple nodes and calculate node. So nodes by path, this to this, click on create. So this I have created. Now I will create an imposed velocity. So to create imposed velocity, I will go to utility, VC manager. I'll put as imposed velocity. I'll name it as imposed velocity. GR nodes to nodes. Direction will be y-axis. Turn this thing off. Geometry also, so that I can select the center node. Proceed. Click on curve. Here it is mentioned that we have to create a curve value as x value as 0, 0 and y value as 25, 25. So I will click on new, load as the curve name, put this value as 0 and 1000, 25 and 25. Click on update, close and click on create. So once you click on create, it will create an imposed velocity as you can see here. So my imposed velocity is created now. So now the next step is I will create a rigid wall. So model browser, turn on this. I can off this surface thing. So I will create a rigid wall. So to create a rigid wall, I will go to tools, R wall, tools, create cards, R wall, plane. But before that, I should have a node to assign it to a rigid wall. So R wall, or I'll show you the other way of creating it. So you can create it, the rigid wall, from analysis page, rigid wall, name as R wall, type as R wall, define a color, size, it doesn't matter a lot, then click on create. So it creates a R wall. Then select a base node, edit, and move this to a y-axis. Let's say 50. Edit. We need it 4, 8. So we made it a point ahead this base node. Shape has to be infinite. And this to be this and this. Return. Then go to add. Set the distance to, let's suppose, 100. Click on update. In cart, go to edit. So this is the base node, and click on update. So it is created a rigid wall. Add nodes till 100. Add, update. You can review this. So it has selected these nodes. We have to check the direction. It has to be opposite in direction. You can see it is in opposite direction. Then in cart, edit. Friction value we have to give as 0.20. So I have done this editing. Then I'll go to interface, enter the name as the interface as self interface, select the type as type 7 and create, click on create, click add, select the components for master and select the boat as the component, click on update. Then for the slave, select the component, again select boat and click on update. Once you click on review, it should look like this, the blue and red patch. Then go to card image, click on edit. Now change these values of static friction to 1, friction value to 0.2, gap minimum to 0.9. Then we will create some output request. The basic output request required to solve these types of problems. So I'll go to control cards. First file is to select the engine title, so I'll go to next. It is all alphabetical, so you can select alphabetically. So I will select engine title. Engine title, name it as boat, then return. Then we will select engine run, so I'll go to preview, engine run, T-stop it is create an output request for NMDT. It has given this values also, the static friction, friction and all. Then we have given the title, so I will then in the run, the T-stop we have to give 10, return, then NMDT, so engine NMDT as T frequency 0.5, then NM element ESEP, ESPS, 1 mices, hourglass, then NM velocity, turnout count, displacement, and F output. Then PRITH engine keyword as on, engine print, N print to -1000, engine run I have already specified, then T file, engine T file, and the frequency as 0.01. So I have defined all the cards. You can see we have defined 8 cards. So now I will save this file as part B. Go to radios and solve this. So this will take some time to solve. So if you follow this step, this file will get solved. If you skip any one or the other step, you will end up with the errors. So whenever you find any errors, feel free to contact us. In between, while it's solving, so now you can see it has solved. So we will see the results. I will off some of the components and then we will see the results of this. So displacement values, this is the animation of the displacement, and the stress so this is the stress and displacement plot for the impact on this. You can create some more boundary conditions if you want to save the end of this from crushing. So you can create one more boundary condition so that it will not move or crushed, so it depends on you. This video or this webinar is for to show you how you can solve the contest model available on for AOC 2015. So in this way I have ended with this webinar. If you have any queries, feel free to ask us on my mail ID, or you can ask us on edu-support@india.idea.com.